Good evening, everyone. My name is Danko. I will tell you about how to use AI with cryptocurrencies. I was asking myself already the same question for a long time. How do you apply AI? I will tell you about our challenges that we have, but very unique, specific challenges, and also what we have done to overcome those challenges. But first, let me tell you a few things about me. I've been for most of my life a neuroscientist, a brain scientist. And here at the Max Planck Institute in Frankfurt. And the reason I've done that was I wanted to steal secrets from the brain to be able to improve machine learning, to improve AI technology. But also, what was very useful for me for these things was going through this scientific process many times, many times, and learning how to do science, how to deal with things that are completely unknown at the beginning. And that's something we needed to do here with cryptocurrencies, because it's a world that's still today very little understood, very little known, right? So in the classical financial markets, you have lots of work behind. Lots of academics have done work, lots of big books written, lots of research done. Here, almost nothing, right? So we had to actually start from sort of from scratch, from kind of a Stone Age thing. So let me tell you about these things. I will begin my presentation with this article that came out a few weeks later. So it's a review of AI in Forex. But the really interesting thing what the author of the article concluded was that most of the companies who claim to have AI for Forex prediction were lying. That's what he said, lying. And he came to this conclusion that from various reasons, these companies didn't show performance, did not show that they have competent teams and so on. But the whole point why I want to bring this up, probably he was exaggerating like journalists often do. But the whole point is that it's really hard. It's really, really hard. When you apply AI to all kinds of other things outside of the financial world, it's easier. There's many other applications that are much more easy. And much of the problems the speakers today already repeated. So I will be a little bit repetitive right now. So there are two main challenges, of course, in the financial world. One is that the universe is not stationary. We have heard that. I will repeat it really briefly. If you want to make AI that recognizes faces, you have faces in the history, millions of faces, and then you train your neural network with this data. Now come new faces next day. These faces are going to have pretty much properties of the old faces. Faces do not change over time quickly. Right? With evolution, maybe it will change in thousands of years, but right now, in this time scale, they don't change. Also, the cars don't change, their shapes, and models change a little bit over time, but not as quickly. Financial world changes really quickly. So whatever you have learned, trained and established in the past may not apply soon enough in the future. We know all that. That's why it's hard. And the other reason why it's hard is that the data are small. Right? We have heard that already from speakers today over and over again. Right? Having financial data from a history is not big data. It's not a lot of data. You can do lots of things on a single PC. You don't need a GPU or a farm of GPUs. Right? The data are not big and not stationary. Right? So in the same time. So it's really a problem. So you cannot just take off-the-shelf simply deep learning systems with millions of parameters, feed in the data, it spits out a model. No, it doesn't. It doesn't spit out good models. Right? Now, when you do crypto, you have extra challenge. It becomes extra difficult. Why? Because what we want to do at savedroid, we want to help people save in cryptocurrencies. And we want to build for them a portfolio, the best possible portfolio for saving in cryptocurrencies. Now, what are our challenges? These two challenges that I mentioned come to the extreme. the volatility, the instability of the crypto world is much crazier than anything else. The world changes about crypto world, thinking, understanding the crypto world, the behavior of the market just changes like crazy. You know, you don't know what will come tomorrow. And today came a total surprise that one of these coins, this one, forked into 2 different coins. Today, they forked today into 2 different coins. You can do it. And there's no need for regulations on anything. Someone can come up, you know, a group of people, has to be a group of people, but they come up with a decision, we're gonna fork for whatever reason they decide. It's wow. It's really wow. So that's a challenge, right? Another challenge is the amount of data. People talk about here about, you know, the universe of thousands of assets. We have, for whatever reasons, some technical reasons, infrastructure reasons, and so on, we can work with 4 assets. 4 assets, 4 different coins. Right now. We can expand over time, but right now we are working with 4. Wow.
5 as of today.
Why? Aha, yeah, exactly, yeah. 5. That we are confused and don't know what to do with that. Exactly. That's one problem. The other problem is the history of data. The history is really, really short, right? The longest history, Bitcoin has the longest history, 7 years. The rest has a history, some have a history of 2 years, right? So how do you do your, you know, back testing if you don't even have any history? So, you know, if you would consider all that, you would say like, I'll give up, you know, don't even try. Why bother? But there's a good reason why you should actually try. Why should you try doing something? There's something great about crypto. And that's that historically, the performance in crypto was spectacular, better than anything else. So what you see here is the entire history, day by day prices of Bitcoin. From day 1 to like a few weeks ago when we made the plot. And that's a logarithmic plot. What it means, if you bought here, invested 1,000 euro, now you would have 100 million. If on the same day we calculate, if on the same day you invest 1,000 in Google stocks, you would have 9,000. Right? So that's a kind of total, you know, there's such a huge difference that kind of says, well, let's look at it. Let's see what we can do. It's extremely volatile, as you can see here, extremely volatile, but spectacularly performing historically. You don't know what the future will bring, but if you take history for the future, you can you know, pay attention to that. Another reason why you want to look at it is that, see, when you discuss about the stock price has to reflect somehow the performance of the company, what the company is doing, how many customers it has, what the prices, profits, and so on. Here, you know, coins don't have anything like that, right? The value of the coin is the price that it has. That's all it has. Like this cycle is immediately closed. And what it has for the effect is that it's completely free to go up. There's nothing that's stopping it really to go up or to go down as well. So that's why you have this huge volatility, right? So, and that's the reason why you could look at something so crazy, right? But there are also hard facts. That slide here is again the entire history of Bitcoin, but now shown as returns. Again, a logarithm of returns. You can see here how big events have been occurring in the past. And everything that's big, means high change. But what you often see is these peaks that have upper part and the lower part, meaning that there was a change towards down, for example, and then surely, you know, soon enough, a change towards up. If you have this vertical lines, so you have lots of these vertical lines, it means that the market is changing its mind very often and very, very intensively, very aggressively. So you have to work in a very volatile world. Also, you know, normally when you build portfolio, you want to diversify. And diversify means you want to have assets of low correlations, zero correlations, negative correlations, right? Well, it's really hard to get that in cryptocurrencies because cryptocurrencies are highly correlated one with another for whatever reason, right, that we don't completely understand today. So what you see here is a correlation of over time in 1 week periods between two currencies, Bitcoin and Ethereum. You see that sometimes correlation is 1. It's very high most of the time, and occasionally you have moments when it dips down really low and then quickly comes back to high correlation. Then again, occasionally dips down. So the correlation is highly volatile as well. So you are limited in how much a portfolio can reduce risk, right? As compared, so if you take just single cryptocurrency, just Bitcoin, or you build a portfolio, there's actually a mathematical limit how much you can do. You cannot do a lot. And we have to work with that fact that we cannot do a lot. Unless, of course, no, I mixed up the slides. Unless, of course, comes maybe next. We have also technical limitations. So for currencies, this I have already said, maybe now it's unless, of course, you have a stable coin. If you have a stable coin, that would be a coin that's tethered to $1 or to euro and basically has the same value. So if you look at the volatility of euro or dollar compared to Bitcoin, it's practically no volatility at all in a relative sense. It's stable. That's why it's called stable coin. If we would have in our portfolio a stable coin, we could then reduce risk considerably. We could regulate the risk by the proportion of this stable currency. But again, for technical reasons, we are not right now capable of doing it, right? So the entire market also depends on infrastructure. All the business depends on infrastructure, which is gradually being built around the world. There are systems for trading, but they are not as good, as efficient, as flexible as in the classical world. The things are being built right now, right? So at the moment we cannot use a tethered cryptocurrency. So we have to work with the world in which we have high volatility, small universe, little history, highly correlated currencies. So what's the result? How do you do AI? How do you build AI in such a condition? So taking some machine learning tools from the textbook, it's completely out of question. It's never going to work even closely to that, right? What you have to do is have to start from scratch. And meaning from scratch, I mean from scratch really deep from scratch. It's like, every machine learning algorithm that exists today, be it neural network, deep learning, be it random forest, be it support vector machine, someone had to think about it and make up this machine learning algorithm. Think of certain types of problems that have been occurring in data and science, and think, how could I address them, and make up this algorithm. That's how low we have to go here. And this basically means doing science. Like, we are data scientists and we emphasize the science word of that. Using statistical theory, using the market theory from the classical market and see how much it fits to the crypto market. Does it fit? To which degree? Which parts fit? Which parts do not? And then using fundamental machine learning theory. So not machine learning tools, but machine learning theories, the fundamental theorems that underlie machine learning, and building from them a solution. And that's what we did. If you want to learn, this is a little advertisement for my my course in Udemy for advanced topics in machine learning, where you can learn these basic things about machine learning. Some things that most of the people who actually do professionally machine learning would learn a lot from this course, because it's not telling you about the tools that you can use, but the fundamental theory about intelligence, what intelligence means, how to get something intelligent, what are the limitations of intelligence, and so on. And interesting stuff. Now, how do you build this? There are basically three strategies you could do. I identified three possible strategies. One I mentioned already, and I'll tell you a little more about it right now. That's doing the science of the problem. Right? These are the questions that we actually asked. I went with my data science team, and we collect the data, clean the data, prepare the data, and then we went asking questions. Let's ask this question, to find the answer, and find out possibly the laws by which the market behaves. Once you have these laws, you can implement them into your machine learning algorithm. Right? As I told you just a moment ago, you build things from scratch. How you build things from scratch? Like scientists did. You know, E is equal mc squared. How did Einstein come up with that? Looking at some data. Did he have big data? No. They probably had less data than we have. Everything back then was paper and pencil. There was nothing else. Paper and pencil and abacus maybe they could use, and that was it. Right? Yet they come up with very, very fundamental cool things. Right? So we could try to do the same thing. We don't have so much time. We don't have so much resources as the entire generations of physicists had. But we could do the same things. Look at the rules, how the market behaves, what is generally regular there, and implement that, describe that directly into the model. So, and we discovered some interesting stuff. So, for example, we found that volatility is extremely important. If you assess volatility is not very reliable. Volatility of today is not going to be the volatility of tomorrow. The volatility of this week is not going to be the volatility of the next week. It just changes quite a bit. It's so wild that the volatility is not reliable, right? So here's an example. First, let me tell you about efficiency frontier, right? So you have classically, probably everybody knows what the efficiency frontier should look like when you have normal market, lots of assets, hundreds of assets in your portfolio. It should look just not like this one, it should just the other way around. If you had this kind of efficiency frontier, all the mathematics that you know classically from market theory would tell you, well, you should pick this portfolio here because they have excellent Sharpe ratio. Except that volatility here is really high. So whatever you have this week here, next week may not be like that. Right? Okay, that's the first strategy that one could use, and we use that one extensively. Now there's a second strategy that I want to tell you. You could have your machine. So the main problem with machine learning on an extensive scale, like the deep learning algorithms, is that you have millions of parameters. You cannot fit millions of parameters with hundreds of data points. You will overfit. We discussed that already. We know that, right? So, but what you could do is machine learning algorithms. And then you have only a few parameters to learn. But first, you machine learn the learning algorithm. So it's like doing science in the first step, but instead of humans doing it, machine doing it. And there actually exists recently research in doing such things. Right? And Google has done a few, for example, 2 important projects. Some other groups have also done some projects. There are some specialized data sets for such projects. But you wouldn't believe that the best machine for doing something like this was developed here in Frankfurt. Actually, I developed it with a group of people. And if you want to check, you can go to this website, Robert's Go Mental, and read more about it. However, we did not use it in savedroid, this type of stuff, because it's nevertheless requires a lot more resources than we had available at savedroid, right? I have a team of me plus 2 people, right? So we have to do work as a team of 3 people. But that's one of the possibilities. It has never been applied yet to financial problems. And the strategy 3 that everybody knows and works well, you let the universe compute for you, right? So if you can't compute things, there's the universe does things. There are people all around the world, there are events happening that if you can extract what they are doing, if they are making decisions, if they are making assessments, if you can extract what they are doing, you can gain information that you cannot personally compute, right? So what we heard a lot was about sentiment analysis from Twitter and other resources, but also another source that does a similar principle of having the outside world computing for you is market capitalization. You probably also all know that there is the theory, the most influential theory in economics says that market capitalization is the optimal portfolio, that it's really hard to beat market capitalization for the reason that the market capitalization is the result of so many agents making decisions, every agent knowing a small piece of information. Only market as a whole knows all this information together, and then therefore market capitalization is your best portfolio you could have. It's really hard to beat market capitalization. Now, in crypto world, you have market capitalization, but what market capitalization means is, again, a little different. It's, again, a little hard to conceptualize it, because what are you valuing? Again, what are you valuing here? Right? Nevertheless, there are a couple of things couple of very interesting things we could do with that. And I'll show you in a moment. But let's make here a summary of these 3 strategies, how they address the problems, right? So we have the problem of small data and of instability, right? So if you do science, it's really good for small data. Science, most of the science that we have still today has been done with small data. But science extracts the regularities, not the instabilities, right? Machine learning to learn addresses to degree small data, but at the beginning it actually requires a large data set. But you can transfer knowledge. You can use, for example, a large data set from stock market to train machine how to learn, and then apply it with small data, for example, to crypto market. And the universe computes. If the universe does the work for you, then you solve the both problems. So what we did at savedroid, we combined 1 and 3. We did science of it. And then on top of, when we understood that, on top of that, we had market capitalization do the work for us. And then on top of that, we do a little bit of machine learning with very small number of parameters, so we make sure that we don't overfit, right? So how do you make sure you don't overfit? There are different strategies we heard today. I think the best one is to have a very few parameters. If your number of parameters is much smaller than the number of data points, then you can, you're pretty safe. Not guaranteed, but pretty safe not to overfit. Now, I'm going to tell you maybe the craziest thing you will hear, and you may throw some bottles at me. I don't know. I'll stay here. Every investment has a certain philosophy, right? There's no one strategy, right strategy for investing. So you have to have certain philosophy. So here's a list of our philosophy. And one of the main things we did when deciding the steps is to de-emphasize returns. So it means that we say, okay, it doesn't really matter. We don't want to optimize for return. And that may sound totally crazy, right? So like everything's about return. Everything's about making money. So why would you not want to optimize for returns? The 2 reasons that combine and together tell you that why you shouldn't do it. First, we have too little data to optimize for return. It's easier to optimize for deal with volatility than return. It's easier to predict volatility than return. Second, returns were spectacular. So if we mess them up a little bit, it doesn't really matter. If you remember this curve that I show you at the beginning, if you just get this a little bit down, doesn't matter so much, right? So basically our goal for our customers and for our own portfolio, because savedroid has also its own portfolio, is to reduce the rocking part as much as possible. If this happens to reduce the return a little bit, we are not worried so much, right? It may improve it, great, but we are not emphasizing it so much. We are more worried about volatility. Volatility is very important. Market capitalization is very important for us, right? And basically what we are doing, in a way, we are in real time testing efficient market hypothesis. We are looking at where the market capitalization is according to certain measures of whether market capitalization follows the efficient market hypothesis, right? It's not given, especially not in crypto market, that efficient market hypothesis holds. And also, it's really hard to define it. You know, you could discuss how do you define efficient market if you do not have all this classical value in a crypto market, right? We look at 1 year in the history plus current situation in the market. Why we look 1 year, not more, not less? We did all the analysis as much as we could make. We had in mind that our users may be saving money for up to 1 year, or roughly in this region. So 1 year of history predicting roughly 1 year of future. And it looks roughly like this. Recent prices, price history, go into AI, optimal portfolio. Human supervision you always want to have, but it's really we're just watching and concluding what has happened. We don't change really decisions. And the sentiment analysis is gray because we are not working on it right now, but it's planned to add later to tweak additionally the portfolio, right? And then comes the action. Now, what we work with quite a bit to set up the whole thing working is it's such three-dimensional spaces where you see return, volatility, and I said volatility of volatility. We look where market capitalization is located in this space, and that's the world in which we work, in which we operate with our machine learning algorithm. There's also one nice advantage when you work with such small data. We can enumerate all possible combinations of portfolios. We can look all of them, right? You don't need to do, you know, sampling or something. We can just look all of them in 1% steps, all possible combinations, because it's small enough, right? And we could have enough computational power to do that. So we could know for sure at the end exactly this portfolio is the most optimal one according to our criteria. We can be sure that there's no another one that mathematically fits better, right? That's at least one advantage. But what very often happens is that market capitalization is not on the efficiency frontier. And each dot is one portfolio. We have a subset of all the possible portfolios. We calculate all of them, but do not print all of them. It's too much for the screen, and then everything's just white, right? The green dots is just one mathematical operation called concave hull, which just finds the outside space of this. And then we look at this outside space, and we are searching for portfolios on the edge, on this efficiency frontier, how we define it, including volatility, that are in certain relationship to market capitalization. And our machine learning algorithm is learning this relationship. Right? I think this may be my last slide. Yes, I have conclusions. Why I don't have a slide of performance? Everyone has a slide, and now it's how we perform. Why I don't have one? Can anyone guess? There's simply not enough history. We started building this 6 months ago, 5 months ago. I started working and building and thinking, doing all this analysis. We started running this several weeks ago. We have first data points. In some versions, of course, it's beating the market. In some versions, it doesn't beat the market. None of it is yet reliable of any meaningful result that I would tell you, look, we can with confidence say, oh, we are doing good or we are not doing good, right? It's just too early. We just started. We just started doing it, and we are still optimizing our machine learning algorithm, or optimizing is not the right word, advancing our machine learning algorithm. So we had first simple version, then we have a better version, solving some equations, and then running the code. So we don't know yet how we will perform, and we will not know soon in any reliable way. We'll have to take time. Right? So a few conclusions. So combining science and AI is really good, really good. We monitor the market on a daily basis. We make changes to portfolio on a weekly basis. It gives us, we think, really good advice to adjust the portfolio. It's beautifully interpretable. It's really easy to interpret the results. Of course, with the assumption that you don't try to interpret market capitalization. Why market capitalization is changing, it may be completely unpredictable, uninterpretable. And of course, AI cannot make miracles. We don't have a crystal ball to predict really what will happen tomorrow with the prices. So thank you very much.
So just one question. It seems that right now AI is not really an application for the cryptocurrency market because of the other things that you mentioned. So at what point, I mean, it seems like it could be make a valuable contribution to the cryptocurrency market, particularly volatility. So at what point do you think it's going to be a realistic application? Will you have enough, when you have enough data? Because the science is there. So
yeah. We are already applying it, and we are already using it. We are gonna we have a beta version of our app. The app will go out live. Depends on technical problems. Maybe end of December, or maybe beginning of January. We hope December, and we will have it there running. One of the reasons we trust it is exactly the science we did behind, right? Even though we don't have a capability to perform, to show the type of results that you would normally expect with classical machine learning, if you do the science part, right, you have also much more confidence that you have done it. I cannot say right, but that you have done the best possible that there could be done, right? And for these reasons, I feel good about having it run, being a product already, and watching how is it doing, and possibly improving it. But there is really not much to improve here. There's not really lots of space for improvement, right?
But even after the app is launched, you still have your own portfolio, which is fairly large. So you will be using that on your own portfolio.
Yes.
For users, right?
Exactly. Yeah. So we have basically two portfolios. So the company has its own assets in cryptocurrencies as a result of ICO, and also our users will be saving in in cryptocurrencies. And we use the same portfolio for our own assets and for the user assets. We trust it enough to put our own assets in this portfolio, right?
Danko, thank you.
Hi. So how do you tackle your first challenge of non-stationarity?
Can you repeat?
The first challenge you mentioned at the beginning, how do you tackle it?
How do I?
How do you deal with it?
The first challenge.
Non-stationarity.
Okay, that's a good question. That's a long answer. So you have to basically to have any solution, any a model, be it machine learning model, be it scientific model, you have to have parameters. Like my example with is MC square. C square is a parameter. It's an estimated number that's valid everywhere in the universe, but it's a parameter. It's the speed of light. Right? So you have to estimate the parameters. Now, if it's non-stationary, there are parts that are stationary, some general laws. There are parts that are kind of stationary. There are parts that are much, much less stationary. So depending on the time scale in which they are valid, and we estimated those through our scientific analysis, we estimate them. So some parameters we estimate a year back. Some parameters we estimate 3 months back. Some parameters we estimate 8 weeks back, and some things we take on a daily basis. Right? So we divided the whole model, if you wish, into components that are stationary, less stationary, really non-stationary, and then we estimate them back on every regularly, always, as the data are rolling, we always change these windows and re-estimate that.
Any other questions today? Thank you very much.
Thank you.